second. Oh, yes. Thank you for starting the recording. The second part of the 5-part series of the science communication series. Last event was the professionals in SciComm. If you were here last week, then you know all about it. And this is the second one. This is our first workshop, and we have with us Parham Pashaei, which thank you very much for coming, Parham. So I am a member of the SAC, and for those of you that don't, the SAC is the Student Advisory Council at the CAP, and the CAP is the Canadian Association of Physicists, for those of you that didn't know. This was formed in 2019 to advocate for students in physics in all of Canada, and to just be a voice for students, and to also help all the communities of physics students across Canada to be together and to be better united. And the SAC at the CAP has organized this series in science communication. And today we have, like I said, the pleasure of having Parham with us. Today I'm joining you from Germany, but I'm a student at UBC, which is, for those of you that don't know, it's on unceded Musqueam territory. And as always, we encourage you to be acquainted with the land that you live in, that you call home, that you work in. And you can do this in Canada, at least, at a website. It's native/land-land.ca. We'll share the link in the description, in the chat, sorry. And there you can get acquainted with the different ancestral lands that people live in. Maybe you live in one and you didn't know, so we encourage you to do so. All right, so let me introduce Parham. Parham is the host of Quantum Bits podcast and is a PhD candidate in electrical and computer engineering at the University of British Columbia. Parham is also the curriculum development lead in quantum computing at the University of British Columbia, and is working to create educational resources in quantum computing with the Diversifying Talent in Quantum Computing project led by the University of British Columbia, Canada's Digital Technology Supercluster, D-Wave, and Microsoft. He's also the former quantum computing education strategist and contractor at Xanadu. And so, without further ado, I will lead the way to Parham, whenever you're ready.
Thank you so much for the introduction, and it's great to be here with all of you today. Thanks again to the organizers for organizing this amazing workshop series. Science communication is personally my passion, and I'm sure all of you are also very passionate about science communication. And I think we are at the time in the world that, you know, being able to communicate based on facts, based on data is more important than ever. And you're all physicists, yes, maybe some of you engineers, and I'm sure you're all really good at this. So it's great to push our communication skills further, and use our skills in for the good of public. So before I get started with the presentation, I just want to share that yesterday when I was preparing the workshop, I was trying to reflect on my own learnings in science communication, like what was my own source of learning science communication before I get started. And I realized in most cases, maybe in all cases, it was always getting something started and learning down the way. So, and I remember I was in this science communication conference called ComSciCon, which I strongly encourage you to check it out and participate if you can. And in the past few years, it's also it's happening in Canada as well. And I realized a lot of other good science communicators also have the same experience. They just get something started, and then they find their own way into science communication. And I think one of the reasons behind that is, we are all from different fields and we all have different skills. So it's a very creative area, and different people have different ways of doing science communication, and our backgrounds are different. So if you are passionate about science communication, if you are interested to write a blog or run a podcast or a video channel, and if you think you don't have the education background of it, don't worry, just get it started. And at the beginning, you might have maybe just your family or friends watching it, but down the road, you'll learn and you'll find your own way to do it. So now I'm going to share my presentation so we can. Okay, I think I don't have access to share the slides.
Try now.
Okay, thank you. Let's see if it works. Okay. Which screen are you seeing? Are you seeing my presentation screen or the screen that has the notes?
We see the title page, the presentation.
Okay, so you don't see my notes. Okay, good. Perfect. So, okay, let's get started with a question. I would like to, have this as a engaging, we are going to learn together in this workshop. So let's get started with your with motivation of the audience for science communication. I'm interested to hear from some of you why you're interested in science communication and what is your motivation. And feel free to use the chat box or unmute your microphone, your camera. Maybe I'll encourage some of the organizers to to start because organizing this event, they might be extra motivated.
I could start off by talking about how when you kind of explain physics to the general public, it gives a better idea of why people delve so deep into physics in the first place, right? So some people say, why do you do particle physics? What's the use of doing such abstract things? And then, you go into why it's so interesting and people kind of get it more. That was my motivation and like delving deep into science communication.
Okay, so am I getting it right? Like it helps people to get physics better and you also learn why people are interested. Is that correct?
Right, exactly. Just helps people who don't normally study physics to understand why people do study it in the first place.
Yeah, so that's a really good answer. One part is that it's helping the audience, but it also is helping you as the person who is presenting. So that's a very important point because you as a science communicator also learn better when you're presenting. But it's also, the motivation is also to help people learn. I'm gonna check the chat box. Griffin, nice to meet you. So Griffin comments that I'm excited about physics and what it has to offer. So to me, science communication is about helping to get others excited about it as well. Fantastic. That's actually what really drives me for teaching as well. Like when I teach a class, when I see the students getting excited, it just charges me for several days after the class. And that's why I teach, to be honest. I like to see the excitement in the students. So thanks for sharing your thoughts on this. So what I hear from you and my other people in science communication is that a lot of it is about the value that we add to our audience or learners. So when we start to think about that, one of the goals of our science communication is to help our audience to get excited about physics or learn about physics or other topics, or maybe for some of them, they want to go to grad school, they want to be prepared. For some people, it might be finding a job, but at the end of the day, it's about putting the learner or the audience at the forefront of our course design or science communication preparation. And once you start being aware of that, once you start putting that mentality in your design, automatically a lot of the pressure, a lot of the feedback from the audience you're going to get is going to change. For example, I personally used to be, long time ago, I used to have my own challenges in presenting to public. I used to get sometimes stressed, maybe be worried about what if I say something wrong or things like that, right? But since I started changing my perspective and focus on the joy and excitement that comes to the learners or the audience, or things that they can learn out of this, I got much more comfortable, and my classes started to be more successful. So it sounds like a simple thing to consider, but it's actually very important, and I encourage you to be aware of that when you are doing something. I'll also read Kyle's comment. Thanks for sharing that. She says communication is important for progress. Being able to communicate science effectively to others at any level is important. So to public, funders, those that are interested, supervisors, colleagues. So based on what I understand, the impact of it is also important for you. That's also a very good motivation. So if we are putting the audience or learner at the forefront of our science communication or teaching, of course, we are grounded in our values. And as physicists, as engineers, as scientists, our values are truthfulness, presenting based on data, validated information, but also we are putting our learners and audience as the core, as center of our science communication or education. So in order to do that, it's important to know who is our audience. And we can have audience from different backgrounds. For example, I've listed some. If you have, any of you who do science communication, have you ever had a unique experience with a background, like with an audience, like an audience with a unique background? If you had, please share it in the comments, or maybe feel free to unmute and share with the rest of the people. For example, I started working with K-12 learners, which is kindergarten to high school. And I started preparing educational material about quantum computing. And, that's a totally different audience from grad students. They have very different needs, and, your science communication methods, everything changes. Any interesting stories from the audience about the background of the audience that you had presented to? So feel free to type in or unmute while I'm going to the rest of it. The other thing is the technical background. So again, if you're presenting to public, they might have a variety of technical backgrounds. They might be doctors, they might be people from finance backgrounds. So you also have to consider that in your science communication. And the other area is the audience interests. So why they're participating in that event. For example, when I was thinking about it, I realized with the Quantum Beats podcast, a lot of people are enthusiasts, right? There are people from different backgrounds, but they are interested about quantum computing. But it could be people who are doing self-study, right? So are there any other interests that you can imagine for your audience when you're doing science communication work? Maybe I'll close the presentation mode and just type your answers. You can still see my screen, right?
Yes.
Okay. Anything else to add up to the audience interests other than self-study and enthusiasts? For example, sometimes people take courses or participate in science communication events for learning something new, or maybe they want to find a job in that field, and that makes them interested. So William, yes.
Yeah, I think sometimes people come into these kind of science communication areas to clear up some misconceptions. So I know that something that I kind of talked about a while ago in my own experience was the LHC, the Large Hadron Collider. Some people thought it could create a black hole and destroy the world. And so I had to like kind of explain to people how very technically that's super improbable but possible. And even if it happens, it's definitely not going to destroy the world. And I think that's kind of an interesting way that the audience comes into some of these panels, kind of looking to kind of point the finger and say, oh, this is dangerous. But then after that, they kind of understand that no, there's no danger in these kind of well understood physics backgrounds.
Right. So clarifying their misconceptions, that's very important. So if you recognize that as an interest or goal of the audience, then you can bring examples that demystify some topics in your field. I'm just going to have a look at the chat box. I see some. So let's see. So, okay, Edward is saying, referring to quantum mechanics for babies, you know, that could also be your audience. It's a very challenging audience. The lower the age group, I find it more challenging. Christian is saying links to current news or media. Is that with regards to the audience, Christian?
Yes, I mean, often we get audience members who are asking particularly about a topic because it's popped up in current news or the media, like the Hadron Collider.
Oh, I see. Okay, that's a really good point. So news is very important also in science communication. Something newsworthy comes up, and then people want, you know, clarification around that. That's a really good point. Thank you for bringing that up. So again, the idea is just to be aware of what your audience is interested in, and once you consider that, there is a lot more that you can bring in for them in your work. So, okay, let's say we are aware that who is our audience, and now we just want to practice and learn how to be more effective in communicating our scientific field to this audience. And I would like to start that with an example, so we can see with an example. So the example I've brought is a paper in the field of quantum computing. This is a quite well-known paper in quantum computing, and it's something understandable by people from different areas of quantum computing, physics, and engineering. And it's a paper that demonstrated that a quantum computer can be basically faster than any classical computer. Have any of you ever seen this paper before or heard about it? Okay, great. So this paper by itself is some sort of science communication because, you know, millions of people have read it. But I've picked up this particular part of the paper, which talks about an algorithm that they have picked for demonstrating that their quantum computer is faster than a classical computer. So this is an example of science communication in my own field, but hopefully you can apply it to your own field. And, you know, if you can see the text, I will encourage you to just have a look at it and just reflect on how you could possibly communicate this to an audience that is interested or enthusiastic about quantum computing, but they are not necessarily from quantum computing background or physics background. They might be chemists, they might be people from finance background, they might be doctors, or I don't know, any field. But you know, they're enthusiasts, so they are investing an hour of time in your lecture. And if there is any volunteers from the audience who would like to share their understanding from this part of the paper in, I don't know, 10, 20 seconds, that would be very nice. So there is an equation, there are explanations of the equations, but, you know, the question is, how can we present something like this to a enthusiast audience? Okay, it's a challenging task, so I'm gonna go to the next slide. There will be more examples, don't worry. So I interviewed the author of this paper. Oh, William, thank you. Please.
Sorry about there must be some lag here, but so your question is essentially, how do we best communicate this like really hardcore equation? Like, for example, the one I'm seeing on the title here. If that's your question, then something I kind of used to do would be to look at this equation, dissect it by every variable. So kind of like you start at the left-hand side, and then you explain what this first variable is that I've actually never even seen. So that would be interesting to me. And then you go to like this 2 to the n, what n means. Then you go to the brackets. And then, you know, it would even be kind of a funny way to engage with the audience when at the end you say, you know, 1, we all know what 1 is, and stuff like that. So I think that'd be a kind of interesting way to go about explaining these really intense equations, such as this, or like stuff like the Schrodinger equation, which kind of seems like gibberish to someone who's never seen it before. So that might be an interesting way to go about it.
Thank you so much for sharing. So you suggest going, you know, step by step, explaining all the technical parts that the audience might not be familiar, and maybe throw some fun elements which helps connect with the audience. Excellent points. Thank you for sharing that. Samuel, thanks for sharing your thoughts on the comments. He's saying perhaps a more general comment, but in this case, I think the general details are more important than the exact technical details. Really good point, Samuel. Thanks for sharing that. In this case, it might be a good idea to create a story with more real-world situations. However, we should be careful of stretching metaphors too far. That's also a very, very good approach for presenting something to a public audience. So what Samuel is saying is that, you know, as far as I understand, looking at the bigger picture, what is a real world scenario? Because that's what a public audience can connect to. Let's say if you can connect them to a real world application, or, you know, give them an example of how this algorithm can be helpful for them. So excellent point. Thanks for bringing that up, Samuel. And feel free to unmute and share your thoughts if you have more thoughts on that. But I'm going to check out the chat box again. Damien is saying, I think that it can be useful to start with something the audience is familiar with. Fantastic point. This is a really good way of, connecting to your audience, studying your audience well, knowing what they're familiar with, and doing saying something that they can connect with. So everyone has a computer. Excellent point. So you are not picking something complicated. A computer, everybody can connect to it. This calculation is something that no current regular classical computer could do, even a supercomputer. Great job. So Damien is suggesting that we use computer, something that everyone is familiar with, as an example to connect them with this quantum computing example as an example and as a comparison. So the idea is to connect to the audience with something that they are already familiar with. And again, this is something that you can apply if you're in astronomy, if you are in particle physics. You can always be creative and think of what people can connect to. So if you're in particle physics, maybe you can use a magnet or something that people have already had experience with to join your examples. Thanks a lot for your comments and sharing them. It shows that you're already good science communicators. But I did interview the author of this paper, Professor John Martinez, and the interesting point about it is that he's the guy who led this project, and he's the author of the paper. So when you have done something yourself, there is normally much more attachment to details. And the magical thing about this person is that at the top of being a really good scientist, he had this fascinating, experiment. He's also a really good science communicator. So he still can present something that he has done experiments by himself to public in a very simple language and in a very easy to understand way. So I'm gonna share with you a part of the interview that I did with him and how he goes through this part of the paper. So let's go through it together.
And the experiment we did was 53 qubits. And what you do is you run a certain algorithm in the quantum supremacy. And in fact, you choose kind of random gates. It's kind of, there's like a generic sequence of gates you can take where you're working on single qubit operations and then 2 qubits getting them connected. And you alternate between single and qubit across the whole array. And that's the generic algorithm. And then, you know, a specific algorithm, you would say, well, I need this kind of single qubit and this kind of 2 qubit. But what you do in quantum supremacy is the simplest thing is you just choose random gates, randomly chosen gates. You know what they are, but you know, they're randomly chosen. And then you get at the end of it, basically a bunch of random selections of all the possible zeros and ones. Okay. So, you know, that sounds like, okay, you're generating random numbers. What's so exciting about that?
Okay, so his talk continues, and to be fair, this recording was like an hour. So he already explained what is a qubit earlier. He already explained what is a gate earlier. So, so there was already some context, but I would like us to you know, share some of, oh, this is, let me get out of, I would like us to, you know, reflect on the way he went through this and, you know, think about how he did. So personally, one of the lessons I learned from the way he went through the paper was that he avoided jargon. Other than gates and qubits that he already explained at the beginning of the talk, it was not in the video that I shared with you. Sorry about that. He didn't use any other jargon that I could recognize. I mean, one of my jobs there was to pick up those jargons and ask them to explain, but I didn't pick up anything. And, you know, there was a lot of things in that algorithm that they used for random sampling that he could go through, but he just skipped all of this and simply referred to it as an algorithm that picks some, you know, creates some random numbers. Is there anything else that you picked up from his explanation? Yes, Susie.
Yeah, I really like that he would talk as if it's a train of thought. So he would go, you know, what is this? What is this? Because I think that also helps A, engage the audience, but B, kind of keep you along the same line of thought, if that's the way to put it.
Like a storyline. Is that word? Like it's like it has a timeline, right?
Not necessarily. I would actually agree to like the contrary, because in your head everything's very chaotic, right? But then when you're organizing ideas, that's kind of how your thought process works as well. You're like, what is this? What do I know? What don't I know? And so the way he's talking is very like synonymous to that.
Okay, so the way of talking, you know, talking as it is like a train of thoughts, like sharing what is in his head was something that helped you to connect with him.
Yeah, because your head is kind of processing it at the same time, or in the way that he's talking as well. Yeah, almost like brainstorming. Exactly.
That's a really good point. Actually, I've heard that about interviews. Some people suggest that when you're doing an interview, do that. Like if you have something in your head, just put it out. So it reminded me of that. Yeah, Edvard is saying it's almost like brainstorming. Good point. Anything else? I think, you know, one of the other things I picked up was communication tools that everybody can understand. So he used a lot of body language. Like when he was talking about gates, he would use his hands. When it's random number generator, he would use his hands. And if you are in an in-person class, you know, you can use more body language to connect with your audience. Eduardo, yes.
And I think along those lines, something that's often overlooked is a good voice, good enunciation, a good volume. Yeah, that helps a lot in communication.
Great, good point. Yeah, that's very important to engage the audience. Otherwise, it might sound boring after a while, especially if it's a long talk. The other thing I picked up was at the end of the talk, he said, okay, we create these random numbers, but what is so exciting about that? What is the outcome? And it's his own research, like it's super exciting for him, but he understands that these random numbers might not be exciting for anyone. Why would people care? So he ends with a question, and he's aware that the audience might expect some application or some result out of this. Let's see the chat box. We have more. Good cadence. Yes, thank you. Feel free to elaborate on that, Eduardo, if you would like to.
Well, I think that embodies my answer. It's just when he speaks, it's easy to follow what he's saying, at least in the way he's speaking, not necessarily what he's saying, but the way he's speaking is engaging regardless of what he's saying. It's a little strange. It's like abstracting his method of communication from what he's saying is what I'm trying to say. I don't know if that makes sense.
Yeah, I totally get it. I think that comes a lot with practice. That's a good point. And I think the other thing also is giving examples, like there were algorithms that were not there, but he also said there are algorithms that you can pick cases like this, there are algorithms you can pick cases like that. So he brought in some examples that might be a little technical, but still it can help for that particular audience that are listening to this. Great. I learned something from your observations. Thanks for sharing that. These are really good points. So if there is nothing else, I'll go to the next one. Oh, there's more. Christine is sharing a tool for eliminating jargon from science communication. Thank you so much for sharing that. It's a really important, it's probably one of the most important takeaways from today's session is just learning to avoid jargon. And I remember, thanks for sharing the link. I'll definitely check it out after the session. But I remember we were in the Science conference, and one of the ways they would encourage us to practice avoiding jargon was that we would give talks and they would give us papers on one side green and on one side red. And whenever somebody was giving a talk, if there was jargon, everybody would turn it to the red side and bring it up. So when you were giving a talk, you would know that it's jargon. So if you want to practice your, improve your science communication skills, you can give a talk and ask your friends to, raise their hands if you're using jargon, because we might not notice it if it's in our own field. Sissy, yes, please.
Do you have any tips for specifically physicists avoiding jargon? Because I feel like we in particular have a lot of terms or just unfamiliar concepts when talking to others that other people who aren't physicists know.
Yeah, well, I don't know if I have a specific to physics example, but I would personally say the most important, the thing that really helped me at least was practice. So I would say that something that really helped me was sharing my passion about my field in parties with people who are absolutely not from physics, and also with K to 12 learners, kindergarten to high school. Because when you are talking to academics like your classmates, they already know a lot of the backgrounds, but when you start talking to a grade 6 level, suddenly you realize a lot of things that you assume that everybody knows is not everybody knows. So I would say practice is the best way to get it, and practice with people who are absolutely out of your field. So if you are somewhere that people are not from your department or not from the university, maybe artists or people with totally different backgrounds, it's a great way to practice that. But I cannot give any specific examples. It's just different from one field to another. But I would say, in short, practice with people who are absolutely out of your field, and you will get a lot of interesting feedback from them. They will tell you, oh, by the way, what do you mean by this? What do you mean by that? Yeah, but that's a good question. Thanks for asking. Now let's go to another example, maybe a little bit more simple, easier example. This is the abstract of that paper. And, I don't know if you can see it. Shall I make it bigger? Maybe I'll put it in presentation mode. So it's abstract of that paper. And again, the abstract by itself is a really good science communication, a written science communication. It's very simplified. But, if any of you have want to volunteer in, presenting it to a general public in 10 seconds, feel free to jump in. It doesn't have to, if it's 15 seconds, still okay. But very, very briefly. You don't have to cover the whole thing, the part that you feel that is more, that connects to the audience better or is more exciting, but at the same time is truthful. I would suggest reading the last few sentences. The last 3-4 sentences are the part that is really good for science communication. Oh, Cici, thank you.
In just 10 seconds, right?
Yeah, 10. 15 is also.
We built a quantum processor that's able to do more and faster calculations.
Great. That was really good. You just read it and you were able to, I think you did it maybe in 5 or 6 seconds. So thank you. There was no jargon. That's very important. You shared your results and you shared something that people can relate to. It's faster and better than regular computing, so people can understand that. So I'll share how I did it in the podcast. Just as an example, when Professor John Martins was going through this, built a hardware that is theoretically capable of beating the supercomputer, and then you identified an algorithm that can demonstrate that, right?
That's right.
So I hope I didn't use any jargon. Did I use any jargon? No, okay, good. So, okay, I just used the word beating a classical computer. It's making more exciting, maybe competitive. But it was similar to what Cici shared. So this was another example. Now, let's say you want to share the same thing, but you have more time and your audience is enthusiasts. So they might go and read the paper, or they might be interested in having more details. And you also have this graph that is hardly visible. Sorry, not good science communication here. But the graph has number of qubits, number of cycles, and it compares a classical validation. Let me use the laser. It compares a classical validation or a classical sampling with a quantum computer. Sorry, I don't expect you to read all of this, but I'm just bringing it as an example. But if anyone wants to try to go through the abstract with more time, and assuming that your audience is enthusiasts, but there are people who are interested in following up and really reading the paper. You don't have to refer to the graph. And you don't have to be correct. You just had 30 seconds to read this. I understand. I think everybody understands. So any trials will be appreciated. You know, maybe this time you can refer to the number of qubits, or this number is 200 seconds, 10,000 years. Everybody understands 200 seconds of 10,000 years. Okay, no problem. Oh, CC again.
Yeah, I can do it if
Our
no one else is volunteering.
Talented star of science communication.
Oh no. I would start with like the first sentence that I said before. So we have a quantum processor that is faster and capable of doing more calculations. And if we're just taking a quick look at the graph on the y-axis, we have a term called fidelity, so how reliable the calculation is. And when you compare it to a classical computer, which is everything written in the gray font, you can see that calculation that would take 10,000 years only takes 200 seconds for this processor.
Fantastic. Did anyone notice any jargon? I didn't notice any jargon. Great job. And you know, you explained the fidelity. You used the word fidelity. You explained it. You referred to the comparison between the classical and quantum computer. What else? Yeah, I think that was really good. And you just read it right now, right? You just read the abstract. So in less than a few minutes, you were able to digest it for public in 20 seconds. Great job. And Eduardo also raised his hands. Are you still interested in giving this a try?
I think yes, and actually, okay, let's just give it a shot. I was going to say something. I just thought of a good analogy for this, and hopefully it works. I don't know. You tell me. So I guess I'll just give it a shot. Sorry. So imagine a lock where locksmiths try to break it open, but it takes the best locksmith in the world 10,000 years. Imagine a locksmith that comes along and is able to do it in 200 seconds. This is the current situation with quantum computers compared to classical computers. So classical computers, quantum computers have reached a point in which they can do a certain number of computations that only takes 200 seconds, which would take a classical computers over 10,000 years, or approximately 10,000 years, and something along those lines, I guess.
I loved it. I love the imagine part, like imagine locksmith, and you know, again, the lock is an example that everybody can connect to, and the fact that you are comparing the numbers is just is so significant that it attracts the attention of everyone. And I think you also mentioned that this is not what this experiment is doing. You mentioned that you just, you know, just imagine that represents a point that quantum computers have reached. So great job. That was very creative. Yeah, so again, avoiding jargon, using examples that audience can relate to, it always works. Kyle in the chat box is saying, we created a quantum processor that can calculate something in under 5 minutes that would take a supercomputer 10,000 years. Yes, very short, very concise, and accurate, no exaggerations. Thank you for sharing. So I'm gonna share how Professor John Martinez did that. And you know, everybody has its own style, like what Eduardo shared might be fantastic for a public audience because they can connect to them because of the example he brought up. CC did a great job in bringing up the figure, and you know, Professor John Martinez will have his own style. So it's no correct or incorrect as far as you are, you know, not using jargon without explaining it, as far as it's truthful and it's not changing the data. So I'm going to share the way he did it. And the first part will be just repetitions of what we listened to a few minutes ago. Right. So in a nutshell, you build a hardware that is theoretically capable of beating a supercomputer, and then you identified an algorithm that can demonstrate that, right?
That's right.
Right.
And in the quantum computer, we took data for 200 seconds. And then the classical computer check would have taken thousands of years, way, way longer.
So there's a clear advantage here.
There's a clear advantage, and you can do it versus number of qubits and show that everything is making sense in a way that you would expect.
Right.
So yeah, it's the basic idea. It's actually a clear, it's kind of like when in computers, you always talk about runtime, right? And then you just compare the runtimes and see if that makes sense.
Okay. So any interesting learning lessons from the way he did it?
He used the term runtime, which I guess, yeah, if I knew more about computing, I probably would have. But if you do know stuff about computers, then bringing in a term that is similar to both quantum and classical is a very, very good comparison.
Excellent point. Actually, I had it on my notes as well. I really love the example that he brought up, because everybody, like most people, can connect to the runtime of a classical computer, and then you use it in the quantum computing terminology. Everybody understand. Any other observations? So one of the things that was interesting for me was that, all he referred to in the graph was like, and you can put different number of qubits and check it with different number of qubits to validate it. So he did refer to the number of qubits that, the different experiments that they did in this graph, but he just referred to it as a as a proof for their experiment. We just did it as a proof for experiment without getting much into the details of it, just the final application. And if there are no other observations, by the way, how did you like this experiment, like this game, like having a paper and going through it and trying to present it to public?
I enjoyed it a lot. I wasn't really good at participating because I'm not in the quantum computer realm, but I quite enjoyed other people's takes.
Oh yeah, thank you for sharing. I think you did try once, and you did a good job. So yeah. Great. So I encourage that people here are from different fields, and probably from astronomy, from different parts of the physics. It's a large field, but I really encourage you to find a good scientist in your field, a good science communicator. Check out their talks, and go and read their papers and see how they normally present their scientific findings to public, how they simplify it. So basically just what we just did. A lot of these scientists have their talks available on YouTube, on radio, so you can go and find them and then read their papers, see how they simplify them without losing the truthfulness and groundedness in data. And if anybody knows any examples from their own field that they would suggest and they would like to share with the audience, please share in the chat box, because I don't know people in all the fields. So I would be happy to share it on the slides. Yes, Eduardo.
Well, this is not my field, but there's a very good YouTube channel. It's called 2 Minute Papers, and it's actually in machine learning and usually, but they take a paper and they make a video about it, and it's always very well exposed. So I really recommend it. It's really good. They always share the paper as well, but due to the nature of the papers, they always have some form of data presentation. Well, obviously there's usually data in most scientific papers, but this one is a very good material.
Thank you for sharing that. I just put it on the slide. Let me know if it's the right name for the YouTube channel. Samuel is saying Scott Aronson is a pretty good time for a very broad range of topics. But it might be difficult to understand his original publications. Yeah, Scott Aronson is a great science communicator as well. I'll put it here. And Cici is sharing a website, Astrobytes. And if my mouse works, put it here. Okay, so yeah, so continue this practice if you can in your own field. And you know, with practice, it gets better. Now let's get back to our first slide, adding value to learner and audience. So one of the ways that we can facilitate the learning process for our learner or audience is basically using engaging the audience by different methods. And in education, this is normally referred to as active learning, or there are different methods of active learning. One of them is experiential learning. So active learning allows you to engage the audience and learner. And once the audience is really engaged, they go through this thinking process, they draw their own conclusion, they remember it much longer. And also the process by itself is a learning. So they learn how to analyze things by themselves. So there's a lot of research around this. If you're interested in education, you can check it out. But it has been demonstrated that it works. So one of the methods of active learning that I found helpful for engineering and physics students is what is called experiential learning cycle, or Kolb cycle. So I really enjoyed using this in the class environment, and I always seek ways of using it in the science communication environment as well. So for example, what we did together today was an example of experiential learning, or Kolb cycle. We started with a paper, with the abstract of the paper, and that was basically our experiment. You know, you had to read the paper and try to think how to present it to public. So that was your experiment for the learning cycle. But you know, in physics, there are a lot of other ways that you can bring this active experimentation to the class. For example, when I was teaching ferromagnetic materials and magnetic materials, I brought some magnets and metals to the class. We did some experiments. The students had some experience. Or we have this superconductivity track in QMI at UBC. And I brought liquid nitrogen so they can really see how superconductors work. So have any of you ever tried doing experimentation in a class or a science communication setup? Or have you ever had a good teacher or science communicator doing an interesting experiment? I'm just going to check out the chat box. Amir is saying, I found the Science versus Beast podcast. Sorry if I'm reading it incorrectly. Very easy to understand, and the host is a very good science communicator as well. Thank you for sharing that. And Carl shared the YouTube channel, Science Without the Gobbledygook. It's in the chat box. But any good experiences with experiments in the class that has helped you to, you know, remember something better? Or
I think in
Yeah.
Sorry, I was just gonna say in first year when you learn angular momentum, and if you have the little like tire on the axis and you're sitting on the chair and then you're like turning it and then you turn with it, I think that's like a great active learning for angular momentum.
Nice. Thanks for sharing that, Cici. So have you had a class that you have been through that, or is it something that you have done in the class?
Both. I was in first year class and then I became a TA and then used the same thing.
Okay. So what was the process? What was the process when you were asked to do that experiment?
excitement because yeah, you're just so excited to sort of like actually be moved by the tire. But then yeah, when you're sitting in the chair and you feel it go in the direction that is contrary to what you would expect, then you're like, ah, okay, so this is angular momentum. This is like, I understand now.
Great. Yeah, that's the whole point. So there's excitement and there is that concrete experience. So, and you said it's contrary to what you feel or what you think. So you had the experimentation, you had a concrete experience, and you observed that it's, you know, contrary to what you feel, and probably you had some abstract conceptualization from that. You learned something out of it, right? So this is what is called a cold cycle. You do experiment, you have a concrete experience, you reflect from it, and you have your abstract conceptualization. So Amir also raised his hand. Amir, yes, please share your experience.
Yes, hi. So yeah, I also had experience with superconducting magnet demonstration, and actually that was the very reason I majored in physics. You know, for my undergrad, I saw a demonstration back in Iran when I was in a high school student, and then when I went to the university, I made superconducting train demonstration in my university. When I came to Canada, I was responsible for, you know, showing superconducting train demonstration, and I find it, you know, it's very tangible way to transfer your experience and to showcase a physical phenomenon. So I find it a very, very powerful tool for science communication.
Yeah, you know, thanks for sharing that. It's actually my favorite experiment as well, and I always love it to bring to the class. I think I enjoy it more than the class, but every time I bring it, but the students always get super excited. They ask so many questions. But you know, one of the things you mentioned was the tangible part. So it brings in a concrete experience, and the audience, the learner, can really reflect on that and can draw some conclusions. So you can design your science communication you know, platform or whatever you are doing, or if it's a lecture, around that experience or experiment, so that the learners can have some reflections and can get something out of it. Thank you for sharing that. Eduardo is sharing something about Richard Feynman. Yeah, linking experiments to everyday experiences and using this cycle a lot. Yeah, I think Richard Feynman was one of the fantastic science communicator and using a lot of experiential learning methods. So we have more examples in the chat box. Sorry if I have to skip some of them, but thanks for sharing your experiences. So this is what I call a learning spiral. It's basically the experiential learning cycle when it's repeated multiple times and gradually raises up the learning and the consciousness of the learner. For example, you know, today we repeated the parts of the paper 3 times. Once we did it for general enthusiasts, once we did it 10 seconds for general public, and then once we did it 1 minute for another audience of enthusiasts with some figures. So in each round, we learned something out of it. Some of you shared that the tonation was interesting. Some of you shared that the jargon there was no jargon. So from each experiment, we learned something together, and those experiments help us to learn better and better. So this is a very powerful tool that you can apply regardless of your field. And one of the ways that you can ask the learner or audience to continue going up this spiral is giving them some task to do it on their own. For example, some of you shared examples of good science communicators for the audience. So people after this lecture can go and search them and they can practice on their own. So this learning spiral can keep going, right? Okay, any questions so far? No. And how much time do we have? Oh, Eduardo, question. Yes, please.
I guess personally for you, is there any part of this cycle that you find is particularly challenging when you engage an audience?
Thank you for that question. So first of all, I want to add that the order that I started cycle it's not always like this. Some educational experts believe that it could be started in other ways. For example, you can start with the abstract conceptualization. The way it worked for me better was starting with the experiment, but you can also start in other areas. And the question you asked was if you find it challenging in any of the steps. I think finding the right experiment sometimes could be challenging. The superconductors are good, cool, magnets are interesting, that you can have some interesting discussions around them, but not everything you can bring to the class, right? So that was a challenge in a lot of the classes. And one of the ways I tried to get around that was, for example, if I cannot do the experiment, I'll bring a video of the experiment. Or if I cannot do the experiment, I'll write it, and you can do it as an exam, right? So you can print it, you can give it to the audience, this is the experiment, try to find a solution for it, like a puzzle, right? So you can get creative, and you don't have to always do a physical experiment. There are other ways that you can do it, but that is the most challenging part for me, at least, like thinking about experiment to bring in the class, and the most fun as well. Valentina, yes, please.
Hi, hello. Yeah, talking about active learning, I was wondering, like, as an instructor, do you think it's like more useful also for the student to like first see, for example, the experiment without knowing what's actually going on? Like they can observe it, but they don't actually know which like variables and forces come into play here, or like first explain the concept and then let them see how these concepts like translate into like an actual experiment?
I think that's an excellent question. And I'm not personally my background is not really like education research. So I remember in the program that I was taking, there was some arguments around that, and people have different opinions. So your question is very valid. Some people believe that you need to first bring that, conceptualization or the theory, then run the students through the experiment, and some believe otherwise. But I think in general, you definitely need some context, right? So whenever we even when we do an experiment, the learner or the audience should definitely have enough context or enough guidance that they can have some sort of observation or a conceptualization out of that experiment, right? So it should be the right experiment for the right audience. So they have enough space and they have enough tools that they can draw some observations and, conceptualization.
Okay, yeah, thank you.
Yeah, but feel free to start, from the abstract conceptualization. Some people start from there. And, there are a lot of papers about experiential learning cycles or cold cycle. You can also check them out. There are different theories that you can try in your classes.
Okay. Thank you.
Thank you. That was a very good question. So getting back to your questions, let's just brainstorm around other ways of engaging learners in the class, because it's very important. When the learner is engaged, they can think about it, they will remember it for a longer time. So, So for example, I find group discussions a good way to get the learners engaged. Any other personal experiences from engagement in class? Or iClickers. At UBC, iClickers are very popular. It's basically a tool that has like 4 or 5 options, and the teacher asks questions, and then when the students answer one of the options, you can see it on the board, so live. I don't know if you have tried it or not, but iClickers are also a really good way of engaging the learners. And nowadays you can also use an app to give live answers to the lecture. The other way is case study, right? So give a case study to the learners and ask them to do a case study in a group. or demos like, I think Amir was mentioning that. Yes, Amir was mentioning the superconductivity demo. This is another way of engaging learning in the class. Any thoughts on more methods for engaging learners?
Maybe virtual reality.
Virtual reality.
New
Wow.
technologies.
Fantastic. I like it. Very engaging. Games as well, right? Games could also be good learning tools. Now, some of this engagement method, you can also use it in a public or science communication setup. For example, asking questions from audience. Just a simple, even if you don't have to get their answers. For example, in the interview we shared, we watched together. At the end of his explanation, he was saying like, what's the point of creating these random number generators? Why it would make you excited, right? Just bringing up that question, it will create some space for the listeners to think about it. Okay, yeah, that's a good question. Why is it exciting? Any other suggestions for engaging audience in the science communication setup? I'm personally very interested to get some feedback on this because it's something that I personally think about. And I think there is less literature around this. There's a lot of literature around engaging learners in the class environment, but for science communication, it's harder to find. I know online quizzes are also popular. I've been to a couple of SciComm talks at UBC by the UBC president, and they bring these online quizzes that you can use your phone to answer or ask questions. And it's not a class; it's like a SciComm talk.
I guess like discussions and examples, like you just said, like.
Mm-hmm. Discussions, examples, perfect. Yeah, examples are a really good way. Like even if you can not have your audience there, still you can use examples. Like Eduardo used the example of locksmith for the quantum supremacy example, for example. Griffin, thanks for your comment in the chat box. He's saying, I've had audience members help to replace jargon through question like, oh, is this like this other thing, where they connect the phenomenon to experience that is more familiar to them. Yeah, that's a really good point. Sometimes the audience bring analogies and examples that is the best example of how to connect to that audience. So then they almost place analogy in your hands to carry through the presentation. Yeah, that's a really good example. So asking the audience to bring examples that they can connect to, and maybe you can use it in your future classes and presentations. And working with K-12 learners, this happens a lot. Okay, thank you for your comments. And the last part of the presentation is about podcasting. I don't know if I have time for that. Maybe I can just go through it briefly in 5 or 10
We've got about 15 minutes.
15 minutes, okay. So we talked about, being audience-oriented, knowing the audience background. We talked about how to communicate more effectively, avoiding jargon, using examples. We did some practice together. And we also talked about engagement, experiential learning, cold cycle, group discussion, examples as a method to engage the audience. But there are also different mediums of oral science communication, right? For example, one medium is this Zoom that we're using right now, but the other ones are audio, like radio, podcast, or video, and live streams or YouTube. So podcasts, how many of you listen to podcasts to learn something new? Eduardo, okay. Cici, okay, 2 people. I also do. Amir, good. So Valentina, okay, you have lots of podcast fans here. And, William as well. Okay, good. And why do you listen to podcasts? why podcast is a good medium for you to listen to. Yes.
Because if I'm in the lab and I'm preparing samples or something, I can just have a podcast playing in my ears. And sometimes I actually find it easier, like especially for the news. If I'm reading the news, I get distracted way too easily. But then if it's just in my ears while I'm cooking, sample prepping, then I can absorb all of it.
Yeah, totally. It's very convenient. I think Christine also is approving. He's saying the podcasts are easy to use on commute. You are in the lab, you're cooking. Very consumable form of media, Eduardo. Yes, I think everybody is on the same page. Any other motivations for listening to podcasts? Okay. And Valentina, yes, please.
Yeah, no, I wanted to say that it's way more engaging than like news. Like I like to read the news, but it's like sounds something very, I don't know, like listening to a podcast feels like you're actually like engaging and like talking to like whoever runs the podcast. So it's nice because sometimes I feel myself commenting out loud what I hear. And then I'm actually realizing that I'm actually talking to myself, but like, yeah, like it's way more engaging than like reading the news, in my opinion.
Okay, that's a good point. Yeah, engaging, interesting. Yeah, at least more engaging than news. Yeah, that's true. Thanks for sharing that, and thanks for sharing Sissy as well. So it's convenient. You can use it in different, parts of your life. It's engaging. And have any one of you ever thought of running a podcast at least once? Like, I don't know, taking a shower and you're thinking, maybe I should run a podcast. Oh, William, great. Oh, Eduardo, more than once. Sissy as well. Good. I'm happy to hear that. So there is some interest in podcasts. Good. So that's good motivation to do this part. Let's do it before we run out of time. So the first thing we need to consider for running a podcast, not the first thing, one of the things we need to consider for the podcast is the format, like what format you would like to run the podcast. So there are different formats that you can run. One of them that I personally tried, I've had 2 podcasts so far. Both of them were in interview format. So I like the interview format because you can learn from various guests on a variety of topics. So you can bring guests who are expert in different topics. You can talk about that topic and people can learn from it. And you can also bring guests who are expert in that field. So the person who will be on the podcast is really a good source of talking about that topic. And also, the content that you are creating is more original because the person you are bringing is really good at that field. Any other format of podcasting that you like for listening, or when you were thinking of running off your podcast, you thought of doing it? Yes, Ria.
But unsuccessfully, yeah. There's this podcast called Black Box Down that explores like the analysis of plane crashes, basically. And I think it's interesting how they have like a case study for each different episode about like this is the issue, and then they delve into why it happened and stuff like that. So kind of this case study format. I prefer the interviews, but I think a case study is also very interesting.
Great, thanks for sharing that. Why do you find it, like, what is interesting about case study that you like?
Well, just it seems that it's a good way to tell a story and learn at the same time. And with the podcast medium, you can kind of listen to it while you're doing other stuff, like for example, cooking, or as Sissy mentioned, while you're doing stuff in the lab. And so like I think case studies, they do well in this format of just listening to someone tell a story about a plane crash or something else.
Great. Yeah, I should listen to more case study podcasts. And some people do book reviews, book summaries, or book summaries actually. That's also a good way to get started. Maybe paper summaries. You can also try that. Yeah, so there. The other one is like having 2 hosts, right? Talking about a particular topic. the first podcast I started, we had two hosts. And the good thing about it was that my colleague was interested in certain areas of that field, and I was interested in other areas. So that would help us to ask a more diverse set of questions, bring more diverse set of guests to the podcast. And actually, if you're planning to start your own podcast and you're not sure if you can commit, or there are areas that you think you might need help, it's a very good idea to start with a friend. So maybe this workshop will be a good opportunity to pair with someone, start your own podcast. And it's also great to pair with people who have qualities that can complement or add up to your qualities. For example, the first podcast I did, my friend was very good at promoting the podcast. He was very interested in marketing, things like that. So that helped us get a lot of listeners in a very short amount of time. And his taste in that topic was different from me, so we could get a much more broader audience. And it's also much easier to get started, like if you're two people. So you can consider that. The other thing is, interview. So let's assume you're doing an interview. I would like to share some tips on doing interview. I also used to work in TV as a journalist, so I also got some experience for interviewing there. But personally, what I do for a podcast, especially science communication, is that I study the guest a lot. Like I read their papers, I read their personal life. I sometimes know what they do for their hobby, like even things like that. As far as it's available public. And if they have done previous podcasts or videos or ScienceCom talks, I go and watch them. So I would say the day before, 2 days before the interview, I just know a lot about them. And then you can have your own way. That's how I do it. But when I'm learning about them, I list questions, a long list of questions, maybe 20, 30. And I don't go through them one by one because I think that will make it kind of artificial. I just have my questions there and maybe practice a little bit. And I try to, add something with a personal connection, so people can relate to. We had someone from the audience, they said when they listen to the podcast, they feel more engaged. So if you add something personal, they ask you start asking like, where are you now? What do you do for a hobby? Things like that. You can gain a better connection with them. And once they start sharing their stories, if you have your list of questions ready, you can ask follow-up questions. So you can have a flow in your podcast or whatever interview you are doing that is not jumping from one topic to another. Because if you're jumping too much, the audience might get confused. So you can have your questions ready, and when it's the right time to ask this question, you can bring it up. And of course, you need tools to get started with a podcast. We're almost running out of time, so I'll go this part really fast. The good news is that the technology is at a really good situation right now. Most of the phones, most of your audio equipment that you use for your daily use have all really good qualities. So if you want to start a podcast, you can just get started with the headphones that you have from your phone, or I don't know, iPhone or whatever phone you have. And the only thing is that try to keep it close to your mouth and minimize the surrounding noise. Things like curtains are really good at blocking external noise, and use a software to edit it. So you can just get started with that. A lot of interviews you see in very well-known channels and media sources, the guests are just using a earplug from their phone, and it's all good. Millions of people are listening. So if you want to get started, you can just get started with that, and down the road, when you get more audience, more people listening, you can upgrade your tools. So if you have already thought about podcasting and you want to have a reasonable audio is very important in podcast, right? It's your voice is the only medium that you're connecting to your audience. You can get started with USB plug and play microphones. They're very easy to run. They're very affordable. You can also use it for your Zoom calls, and if you play music, you can also use it for them. And the quality is very good. If you are planning to do in-person interviews, some of them have a mode that can record from 2 sides. So keep that in mind if you're planning to do interviews. And the problem is that they are not very expandable or upgradable, but they are great starting point. And one of the famous ones is the Blue Yeti, which is like $150. If you want to start, if you want to plan ahead and run it more in a more expandable way, you can get what is called XLR microphone. I'm going to finish in a few minutes. XLR microphone. So XLR microphones, I do have one here. Basically, they just send the audio signal out in an analog way. It's not digital. So you need these XLR cables to connect to your microphone. And the advantage is that if you are doing an interview and you have a guest, you can buy another microphone and connect it to it. And then you need the advantage, or also the disadvantage of XLR microphones is that you will need audio interface like this one. I mean, it doesn't have to look like this. There are more simple versions to connect your XLR microphone and get a digital output to your computer. And then you can connect multiple microphones. So if you have a guest, you can also connect that, or you can connect your headphones. And from my experience, order a good arm, this thing that holds the microphone, because if it's not good, it's gonna add a lot of noise to your podcast or recording. And then finally, you have to edit it. So whether you're recording with your phone or whatever microphone you're using, editing can help you to cut off the excess parts of the recording. You can have peace of mind. You just talk whatever you want with your interview or your friend, and at the end you can cut it. You don't have to worry when you know you are editing. You can also work on the noise, like if where you're recording your podcast there is a lot of noise from the environment, you can just fix it in the editing. So there is a free software called Audacity. You can use that for editing. Or if you have access to Adobe package, you can use Adobe Audition. So I think UBC staff, if you're a TA at UBC, you get access to Adobe package. And if you're already familiar with Adobe Audition will be easier for you. If you're not already very familiar with Adobe and you're not very comfortable, you can just start with Audacity. It's free and it's very easy to use. And I personally use Adobe Audition just because it's very compatible with Premiere and other formats. And maybe I'll finish here. The last part is publishing. So there are different environments you can publish. Spotify, Apple Podcasts, Google Podcasts. So it's not that difficult to publish. You open an account there and you post you get approval after a few days. You write the description of your podcast, you post your first episode, and it sometimes takes a few days for them to respond. Hopefully they'll approve. It's normally not a problem. And you can get access to a lot of statistics from these platforms. But a really good publishing tool for podcasting is Anchor. I really suggest it because with Anchor, you just post it to Anchor, and Anchor publishes for you on Spotify and Apple and Google and many other platforms. So if you don't want to spend too much time and going on all these platforms and individually uploading your podcast, you can just use Anchor. And it gives you a lot of statistics and data about your audience. So there is information about the age, the location, how long they're listening. If you want to get access to all the details of the statistics, you need to also open accounts on each of these platforms. Anchor doesn't give all the information. And one tip, record as many episodes as you can before launching, maybe a couple of episodes. So if there's a time that you cannot find a guest, you will still have something to publish and you can keep it consistent. And again, work with someone who is maybe you have friends who are musicians and are good at audio, and they might be interested in helping with someone doing a podcast. If you can get help from them, or maybe you have a friend who is good at social media, you can get help from them and you can start a podcast together. It will help you to be more, learn teamwork, do it more productively, and also save some time. And yeah, I just wanted to talk about running video channels, but I think it's okay. We already covered a lot of topics here. And I also wanted to share my last tip, and that's maybe a little different from the rest of the presentation, and that's meditation. I personally find practicing meditation very helpful in becoming a better science communicator and educator. And I think that comes from the fact that in the university, in the academic environment, UBC is not, the UBC motto is a place of mind. So our mental faculty, our analytical faculties gets very well developed in the university, but there are some meditations that help you to increase your awareness, your consciousness, or basically develop your heart. So I personally find it very, very effective to give me the personality that can help me to become a better educator or a science communicator. So there are lots of different meditations that you can try, but the ones that work on awareness, consciousness, or developing your heart, or like Zen, Dhyan, things like that, can particularly be very helpful, at least based on my experience in developing your education and science communication skills. I don't have any research-based backup to support this, but it's just based on my personal experience. And yeah, I would like to end the session here, and thank you all of you for your participation and engagement. Yeah, thank you so much.
And with that, we conclude our oral science communication workshop with the one and only Parham Pashaei. Thank you very much. Good round of clapping emojis for Parham, please. And a good round as well for the other Student Advisory Council CAP members that have joined us today. Some of them helped us out with everything today. Thank you for everybody that joined, that tuned in, and we as well invite you to tune into the future parts of the 5-part series, the next one being May 26th at the same time. And this will be the visual scientific communication skill workshop with Mark Belan, the one and only. He's a scientific visual communication specialist at Visual Capitalist. So please tune in. And like I said, there's going to be 3 more parts other than this one. So visual is next week, and written will be sometime in the future. So please join us. Please keep in touch. And thank you all for coming.